All right, so this last part, um, we're going to use something called Cramer's rule. Cramer's rule is a way to solve systems of equations, and it is a way to do it. It may not be the best way, but kind of depends, I guess, on your preference. Um, it can, I mean, it's certainly a foolproof way to do it. Um, but we'll see. I mean, it just depends on your preference, I guess. If you prefer this way or prefer some other way, I guess it just depends on you. But we're going to learn it, and you can use it if you like it, and if not, um, you can use another way, I guess. But the basically, if we have two equations, two variables, um, we can find, and we're solving for x and y. You can see we have a fraction of determinants here. And so the bottom determinant in both of these is just the coefficient matrix A, B, C, D. The numerator, we're either going to replace the x column with, so recall from the last section, AX equals B, where A is the coefficient matrix, X is the column matrix of X and Y, and B is the column matrix of RS in this case. So we're replacing the AC with the answer, or the B matrix. With Y, we're replacing the Y column with the B matrix. And then once we solve those, we get the answer to the system. Um, and we could expand this to however large of a matrix you want, or you're given. Um, so let's look at an example. I think it might be easier if we look at actual numbers here. So we have a 2 by 2 system here. So we're going to have a 2 by 2 determinant over a 2 by 2 determinant. And so the bottom is just going to be the coefficient matrix. And then the y will have the same denominator matrix, or determinant, I should say. And then here we're going to replace, so that this is representing the x's. We're going to replace that with the -1 and the 2. And then the y column is going to say the same. And then over here, we're going to do the opposite. So the x column is the same, but then the y column is replaced by the B matrix. Now it's just a matter of evaluating these determinants. So we have -1 times 8 minus 6 times 2, and then over 2 times 8 minus 6 times 1. So we have -8 minus 12, so that'd be a -20. Over 16 minus 6 would be a 10. So that gives us -2 for x. And then for the y, we have 2 times 2 minus 1 times 1. And then this is just the same, so this will be a 10. So we'll write that out again. We have 4 minus 1 is 3/10. And so there's our solution. So it is faster, especially if you prefer doing determinants. It can certainly be faster. So let's look at the 3 by 3 case here, and I have this one worked out. So I won't write all the details of the determinant. We'll set it up, and then you can check me if you like. But this expands to whatever size matrix you want. Obviously, the bigger it gets, the longer the calculation is. But the bigger the system of equation is, the longer it takes, no matter what method you use. So let's look at this 3 by 3. So the x would equal, and so we'll kind of set this up in the same way. So the bottom is just the coefficient matrix again. So 2, -3, 4, 1, 0, 6, 3, -2, 0. And then we're going to replace this column with the 105. So we have 105, and then these two columns are the same. And then we have the Y, and we'll try to squeeze them all in here. The bottom determinant is, well, I will write it out. We'll write it all out. Just so we don't get, oops, +3. And like most things in this matrix chapter, you got to be very careful to make like any little mistake will mess up the whole thing. Although in this case, one mistake on the Y doesn't necessarily mess up the X and the Z. So you could technically get two of them right and one of them wrong. Whereas the other methods, if you mess up one thing, probably everything is messed up. So maybe this one does have an advantage in that way. Then for the Z, 213, and then -3, 0, -2, and then the 105 will be in the last column. And so I will let you do all the calculating. I already did it beforehand just to make the video shorter. There's no need to go through and calculate all these determinants. We did a 3x3 determinant in the first video. So you should get so -38 is the denominator in each of these, but when we reduce the fractions, well, we'll do the unreduced fractions. You should get -78 over -38. That reduces to 39 over 19. For Y, you would get -22 over -38, and that reduces to 19 over, or 11 over 19. And then for Z, this one actually does not reduce. You get -13 over 38. And that would be your solution. So if you don't mind calculating determinants, these are not too bad. And especially you don't have to do this one every time. Obviously, the denominator is always the same. So do the denominator once, and then you just have to do each of the numerators. And maybe they're easy, maybe they're not. Like in this case, we have that row would be the row to use. And this row would be the row to use. And this one, just pick either the second or third row. Doesn't really matter. All right. So if you have any questions, feel free to email me.